Okay. Let's see. So we were in the middle of this. We need to do this now. Okay, so to go from decimal, let's redo all this. 3, 4, 6, 7, 9. Okay. Let's list all these out, maybe. Yeah, I think that's a good idea. So we can do this. This is 0, 0, and then we'll have 0. Let's see, like this. And this is 1, 2, 3, 4, 5, 6. It's a little annoying, but that's all right. 7, 8, 9, and this is where things change, right? It's A, B, C, D, E. And then, we had this all, and I deleted it. That's okay, though. Let's just do it real quick. 0, 0, 1, 0. Let's do this to maybe... let's try and speed this up a little bit. That's correct. Then it's this 1, 0, 1, 0, 1. I think this is 1, 1. This is 1, 1, 1. This goes here with all zeros. That's here. 1. This is 1. This is 10. So it'd be those two. Then it's 1, 1, 0. That's not right. That's 12. It'd be this, this. This is 0. This is 1, 1, 0. This is 1, 1, 0, 1. And this is 1, 1, 1. And that's all the, okay. Okay. And now we need to go here. This is the octals, right? 3s. Octals in binaries. And that's all that is like, we go here. Let's actually do this like this. And this is all just the binary minus 1, and we can't go as high, right? So ugh. It has to be like this. And then it would start like this, right? Let's finish this and then we'll maybe see how it works. And it can only yeah. I think I understand that, right? It's like how do I represent well, I guess it doesn't matter then how I convert octal to decimal because I can go from octal to binary and binary to decimal, right? Like I don't need to know see, is that 8? It's not. 8 would be, there is no 8. So how, let's see here. I don't think we can represent 8. No. So this is, so what would that become? 1 and 7, which would be this. Let's find out. Like, how does it loop around? That's what I'm not understanding. Maybe I'm being a bit silly. 8 in octal is 1. Oh, there it is, 1 0. Right? So it is quite literally so then what's 9? That if that holds true, then 9 would be 1 1. I don't understand. Is 11. Okay. I think this works. Oh, and then I need to see what is 16 in hex. Is also 10. Because we go back So then it's not going to matter until I get to 26. One A. Okay. So let's do something here. Let's do fun convert maybe it's binary to octal. No, I don't want that. I want what I want is decimal. Decimal goes to binary, goes to everything else. That's what I want. So fun. So I think the first thing you do is val octal compat equals binary if binary dot length mod 3 equals 0, then binary else binary dot pad start I don't even know why I'd do this. Okay. Okay. Then we would loop over for what I'd probably do is then do bits. So 4. Actually, I in bits dot indices step 3 val a equal. Do I need this? How do I do this? How do I do this? If I take each one and then convert it to a number, I should always end up with a number less than 8 because I'm only taking 3, right? So byte equals, I don't know if what I'm doing makes sense, but it's what I'm doing for now. A bits 1, 0, I plus 1, I plus 2. So I can look at 3 in a row. Is there a way to split it up by 3s? Probably not better than this. So let's just do it. How to do this actually. Kotlin? Oh. That's some real crazy code. Let's see though. If I'm even close. Although I don't really like this. Yeah. Converted. So right now if I run this, it was 101 and 2. Okay. So if base number. Oh. I don't know why it's saying this. What are you talking about? Okay, I see now. Yeah. So I know that this will probably get, we don't need it there. What I probably need to look at is this, and then probably something here. Okay. This is also wrong, I think. I think I need to do this. All right, debug this. 101, 8. So yeah, all right, looks nice. We add a couple of zeros. Let's check that. 1, 2, 3. 1, 2, 3. So we only have one, which means we would need two more zeros. 1, 2, 3. 1, 2, 3. 1, 2, 3. Nice. If we move on, octocompat split. Oh, fuck. I don't. Shit. There. So we have a size 9. Let's see what's going on here. It should be 1. Yeah. Dude, I like. Eyes 3. Decimal 4. Let's read it. 1. Yeah. And then this one should be 4, 5. 1, 4, 5. Oh, that's right. What is 101 in octal? I'm pretty sure that's right. What? The octal representation. Oh no. Sorry. Okay. So that was to get out of binary. Now let me think here. Yesterday, I imagined a function that was just convert, and you would pass the decimal representation as long, and then target base. In this case, we can call it radix, right? I mean, that's what we're doing. And it sounds like we have a function here for that, but you know, we'll build it ourselves. So this is what I imagined, and I also imagined it might be possible to have some mappings. So like the decimal and binary makes sense that it should be 2 and 10. But what I imagined is that the decimal would go by 16. No. Yes, 16. So you divide by 16, and then the non-binary. So like, oh, I wonder if I could just do this, right? Let's see. Var octal long. And this would equal 1. Start there. And you times it by 8, right? This might be a rabbit hole, but I kind of want to explore it. I have a feeling it might be closer than I think. Actually, here, let's pull this out. Put it here. It says n. N needs to become N needs to become decimal. Oh shit. Okay, this is n for now. Now octal. Let's do hexadecimal. Oh no. And this needs to be times 16. Why would this work? Maybe it wouldn't. But it stands to reason in my head that if decimal and binary, like if everything can relate back to binary, this should be pretty close, right? So now, what happens here? What do we check? We check if the decimal representation I think I can clean this up if I can get this to work. So these presumably would need the same treatment here. These are divide and divide. I wonder if I can just print this. Like we'll convert to binary, but like let's check it, right? Let's see. So let's pause. Not here, maybe here. And then we'll go here. Okay, so let's stop this, rerun it. Oh, shit. Convert to binary. Oh. Okay. Remove 1. That should satisfy it, and then I also need to change this to convert. Decimal number and base number, although I'm not using it yet. Okay, so now I just need to do 101 and 2, right? Okay. I think don't think this is working. I think I see the problem too. It's not that octal needs to increase by 8. It's that decimal needs to increase by 8. Right? I still don't know if this is really going to work. So I never got anything even close. What if n is decimal, but we don't do that, we times it by the radix, which means we'd also have to divide by the radix. And now binary was increasing by that. I don't know how you would do this. I don't think I can, to be honest. I'm not sure. Because if I look at octal, right, this also increases by 10. 11. This is a rabbit hole, and I don't think it's going to pay off. Or at least I can't see the light at the end of the tunnel right now. I feel like there's something to do with these bases. But even if I did this right, how do I weave A, B, C, D, E, F in, you know? Okay, so what I'll probably do then is not that. So that's convert binary to octal. All I really have to do is convert binary to hex. So binary string. Oops. Okay, I think that was worth looking at. There's got to be a way to do this. I just don't know how to do it elegantly, and I don't want to waste all my time like barking up this tree. So I'm gonna dip out on this. We'll probably still have something like that, but it's gonna be more specialized. So let's do this. We'll need, let's see. So hex is a bit different, right? We'll need we'll need to make sure that it's mod 4. Yeah, mod 4. So we actually just need basically the same thing. Almost exactly the same thing, but it will change here. Okay, so I have a feeling we could make this a little bit more generic, but for now, let's just do this. Okay, so that should pad us with enough indices. Step 4, we can get rid of this and do bits I plus 3. Oh my gosh, this is so ridiculous. 2int jet output 2 string. I actually don't know if this is ridiculous. I just imagine that convert to binary. Someone who knew what they were doing could probably do this better. Else if base number equals 16L. Actually, here, let's just do when, we could do this now. When base number let's do 2L. Let's just finish it. And then 16L. Oh. That's a little better. Okay. Should we try this? Oh! Cool. Oh, what the fuck? It's telling me to do it right here. So if I did, let's try this one more time. Wait, you just do the remainder? Wait, can you do that with binary too? You just mod it? So on a second. Did I just do all this work for nothing? Oh my god. We don't care about this. But here, let's just do quotient remaining. Before I do that, you would do no way. It would be so sad if this is all it is. Oh no. Let's try. I mean, I guess it's cool to learn this, but it feels bad, man. Not gonna lie. I thought I was onto something there, and it's not even close, dude. What? Oh no. Okay, so it says 110 is 156. Let's try it. 110 and 8. Oh, I forgot to. I don't know what's going on. Infinite loop, probably. Did I forget something? Remaining quotient minus. So let's do greater than 1 maybe, and then let's just add a break here. Let's see what happens. Bro, that feels so bad. 6? Oh no. 1. 5. Alright, something obviously is broken here. What is this giving me? Stop, rerun. Remaining quotient. Oh shit, I'm out of time. That's not good. Let's see if I can't solve this little function right here. 110 and 8. Why did this not work? Close this. Remaining quotient is 110. What is it after I'm done with it though? 97. Why? Oh, okay. So you don't do. Bro, am I losing my mind right now? I think so. You don't do minus equals remaining quotient. You do equals divide equals 8. You just divide it by 8, I think. Oh man. 13. And I just need to add the 1. But hold on, because there was one other thing I did. Let's do Let's add the 0 back. I want to know if that was actually an infinite loop. 6, 5. No, it wasn't. Alrighty then. This is quite literally all I have to do, and instead you could probably do radix here. Oops. Which is a long. And I wonder, this is almost what convert to binary 2. And instead of this, I will do radix. Don't tell me this is how you can do binary too. This is so disappointing. I literally thought I was slick, bro, and it's not. Just comment this out for now, and then convert to binary 2. This will just be 2L, right? So stop, start, 101 to, oh, wait a second. It's backwards. It's just backwards. Oh my gosh. And then we just need a little, we need like a special case for we need like a little bit of special handling for hex, and then we'll be good. Brutal, dude. Look at all the shit I wrote. Alright. Lesson learned. I should have read this closer. It was telling me to do it this way. Okay. Yeah. Lesson learned. Okay, yeah. I kind of am happy I did this because it's making it that much more powerful that I'm just an idiot. Alright. Right on.